Hello. Now that you have some fundamental understanding of the vibration of particles, now do you have some fundamental understanding of the vibration of particles? You are familiar with this vibration. Now, in nature, these kind of simple harmonic vibrations are rampant. In fact, energy transferred from one place to another. How do we transfer energy from one place to another? It is actually one very popular way of doing that is by setting particles into vibration. Now, I want you to watch this simple illustration I have set up for you. Now, here I have constructed a medium. Now, what is this medium? I have a tape, and on which I have stuck some very light straws. Now, if I can set one of them into vibration, all right, I want you to watch and think about it carefully. If I give it a little jerk on this one, this will vibrate up and down. And because each of these is connected by means of the tape, the energy of vibration will get handed over from particle to particle. I'm going to call each of them a particle. Now watch carefully how they vibrate if I set the first one into vibration. Now, there you are. Do they all vibrate at the same time? No. Now, what's the difference there? If this one starts vibrating, the next one starts vibrating a little later. The energy gets to each of these particles a little later, and as a result, each will vibrate. I'm going to develop this word, you've got to understand that. Each will vibrate in a different phase. Now, look at that. Each will vibrate in a different phase. Another illustration of energy transfer through a medium. I have now here a stretched spring. I suppose you can see that. Each segment of a spring is actually a particle. I can set one particle into vibration. Tell me what happens if I pluck, I'm going to pluck this upward and leave it. Watch what happens. Can you watch what is happening? The energy that I used to pluck it up and down, transferred all the way to the other end of the spring, gets back and forth. The energy travels through the medium, and you can see it takes time for each particle to get energy from the nearest particle. This brings us to an important phenomenon in nature called wave motion. What is wave motion? Well, let's look at a couple more examples. If you tie one end of a rope to a support, stretch it by pulling it on the free end, and give it a sudden jerk upward, well, just like I did it on the spring. Now, this is what will happen. The sudden jerk will set the particles of the rope into up and down vibration, and that energy of vibration gets handed over from segment to segment until it reaches the other end of the rope. Then that energy gets reflected back. Now, this is another illustration of the same phenomenon. You can see a pulse that I generate here. The pulse will move gradually to the right. Well, it happens actually very quickly because the energy, the elastic force binding the particles together are very strong. So you see a pulse moving along the rope. When the pulse reaches the support, it gets reflected back, and you can see how energy travels back and forth through the medium of the spring or through the medium of the rope. So the jerk, the energy of the jerk set the segments into simple harmonic vibration, up and down vibration, and the energy of vibration gets handed over from particle to particle. The energy of the jerk gets passed on from segment to segment due to the elastic properties of the string. You see that? It's the elastic properties that binds the particles together. Now, remember, the rope segments do not move away from their positions. The rope segments simply vibrate up and down like this particle. You see that? Each segment executes simple harmonic vibrations just like the simple harmonic vibrations of the spring, and the energy gets transferred along the medium. Okay, the energy of vibration travels along the length of the rope. Each segment of the rope is set into vibration a little later than the previous segment. Do you understand why each segment starts vibrating a little later than the previous one? That is an important concept. All right. Now, you can see here the vibration of the spring, and if you create waves in water, have you actually seen how waves in water can be created? If you drop a pebble into a pool of water, you can see the water will keep moving up and down, and that up and down motion of each water particle is transferred from particle to particle. The energy transfers, energy travels along the surface. You can see if you keep an object like this on the surface of water, you can actually see that object does not move away. That object will simply move up and down in simple harmonic motion. Try it next time. Take water in a wide container and drop a pebble into it, and keep a small piece of paper at some point on the surface. You can see that paper will simply move up and down. The energy will go past it, but the water particles are not moving away from their positions. It's very important to understand that. Alright, so when a pebble is dropped into a pond of water, the pebble sets the molecules of water into simple harmonic motion, SHM, just as the oscillations of this loaded spring. As the energy reaches each molecule a little later, you can see the wave profile is created because the energy reaches each particle a little later. When a particle here has vibrated all the way up, a particle here will just begin to vibrate. You see the profile of the wave. We will create the profile as we go on. Each subsequent molecule will be in a slightly different phase of vibration. I want you to understand this. I will develop this in our next couple of slides. Now, it is this progressive phase difference. If you move from particle to particle in a medium, there will be a progressive phase difference. And it is that progressive phase difference that creates that wave profile. So, if you understood anything what I have said so far, we can use all that concept to define wave motion. What is the definition for wave motion? We can say wave motion is a kind of energy transfer in a medium. The medium may be water, it may be the straws with the tape, it may be the spring, it may be air, you see? So energy transfer in a medium due to the vibrations of the particles of the medium, with the particles themselves, without the particles themselves moving away. You see, each particle will simply vibrate up and down. This particle will not move away from its positions. It will stay in its equilibrium position. The particles themselves do not move away from their respective positions. Alright, now let me see if I can show an illustration to you. Now here you have an example of a medium. I have constructed a medium here by lining up some students. You can see if they are holding hands, one goes up and down. Look at how the energy of vibration get transferred from one. I'm going to call each student a particle. The first particle begins to vibrate, the second particle begins a little later, and look at the profile gets generated. Now this is called a wave profile. Now what is the profile due to? The profile is due to the fact that there is a progressive phase difference between particles in vibration. Alright, I think we have been using this word phase difference quite a lot. Let's now try to understand the meaning of that.